When a ring is used in critical applications like turbines, bearings, wind towers, oil and gas equipment, aerospace, or energy systems, the manufacturing process matters as much as the material itself. Two common options are ring rolling and forging. Both can create strong rings, but they are not ideal for the same requirements. Ring rolling starts with a heated donut-shaped preform. This preform is expanded under rollers to create a seamless ring with controlled diameter, wall thickness, and continuous circumferential grain flow. That is why ring rolling is often preferred for large diameter rings, bearing rings, gear rings, turbine rings, wind tower flanges, and large industrial flanges. The biggest advantage is consistency. Ring rolling gives better OD and ID uniformity, less material waste, better repeatability, and strong fatigue resistance because the grain flow follows the ring direction. But forging a ring can still be the better choice in some cases. Forged rings are usually made through open die or closed die forging, followed by machining. This works well when the ring needs complex features, heavy thickness, special profiles, integrated bosses, holes, or very low-volume production. So which process is better? For large, seamless, fatigue-critical rings with uniform wall thickness, ring rolling usually wins. For custom, complex, very thick or low-volume rings, forging can be the smarter route. But for critical industries, the real differentiator is not just the process. It is documentation, traceability, heat treatment control, UT, MPI, dimensional inspection, hardness testing, impact testing, and certification alignment. Common failures happen when the ring is rolled but not properly certified, when reduction ratio is incorrect, when heat treatment creates brittleness, or when poor inspection misses internal defects. In the end, the best ring is not just rolled or forged, it is manufactured, inspected, and documented for the application it must survive.